Dominating the aviation industry is a top priority for any nation, and the US Air Force is on the verge of shortlisting their 6th-gen NGAD fighter jet. Do you want to know about the upcoming revolution these NGAD fighter jets possess? This new marvel of a technology is going to replace the Raptor F-22. This video is going to take you through the beginning of a new era in air supremacy. But wait, there is an entire legion of about 200 blueprints for next-generation air dominance fighter jet ready for manufacturing. These fighter jets will shock the entire world. But what's in store for the NGAD family of systems? The NGAD, Next Generation Air Dominance Fighter, is not just a single aircraft but a comprehensive family of systems. At the core of this family is the PCA, Penetrating Counter Air, which is a manned fighter aircraft that serves as the centerpiece. The PCA is designed to be highly advanced, hyper-stealthy, and optimized for the integration of drones. For this, they've made some amazing modifications that set them apart from the traditional fighter jets. But what are the changes they've made? Key design elements. The first thing that stands out is the tailless design. Primarily aimed at increasing the stealth capabilities, a vertical tail can increase the aircraft's radar cross-section, making it easy for the radar systems to detect. Moreover, vertical tails can hinder the performance and speed of an aircraft by creating a drag. A tailless design improves the aerodynamics and overall efficiency. One approach is the use of thrust factoring engines, which can provide enhanced control and maneuverability through the manipulation of thrust vectoring. Additionally, the flight computer can employ innovative utilization of existing control surfaces to optimize maneuverability. Furthermore, to maintain its stealthiness, the NGAD fighter incorporates features to reduce its infrared signature. The fighter's engine exhausts are designed in a way that minimizes the thermal emissions that can be detected by infrared search and track IRST systems. This is important because modern defensive platforms rely on IRST systems to detect stealth aircraft. By reducing its IR signature, the NGAD fighter becomes harder to detect. Although the NGAD fighter may not prioritize super maneuverability as its primary objective, it still maintains a high level of agility and responsiveness. Wait, there's more. The integration of drones allows for expanded sensor range, aerial interception capabilities, and the formation of defensive screens, which all contribute to a more comprehensive and integrated air dominance platform. Now, the more pressing issue is the heat. Thermal management is important for any NGAD fighter jet as it generates a lot of heat while flying, especially at the leading edge of the nose. To address this, the fighter is likely to use advanced materials like next-generation radar-absorbing coatings or RAM coatings. These coatings not only absorb or scatter radar waves but also help reduce the aircraft's heat signature, making it more difficult for detection. F-22 Raptor testbeds. To remain undetected, the NGAD has learned a lot from its predecessor. Test flights of F-35s with chrome or mirror-like finishes suggest that they're likely being used as testbeds for the newer RAM coatings. The cockpit only has 2 windows, unlike typical cockpit designs, which can be a source of detection. Pilots are likely to use upgraded helmet systems that offer visual data from cameras installed throughout the aircraft. This technology, known as the Distributed Aperture System (DAS), is already in use on the F-35 and allows pilots to have a 360-degree view, even viewing behind them and through the aircraft. The next problem was the F-22 Raptor being able to carry external fuel tanks and rely on airborne tankers for aerial refueling. The NGAD fighter is armed with a large arsenal of weaponry while remaining stealthy. Internally, it stores its weaponry in bays near the back of the aircraft. The outer bays are for lighter armaments such as air-to-air missiles that can be utilized for defense or air-to-air superiority operations. Inner bays have a larger carrying capacity and are intended for heavier and more powerful weapons such as laser-guided bombs, cruise missiles, and maybe nuclear weapons. Shortcomings. But there's a downside, and the NGAD fighter jet is not perfect. It's a successor to the F-32 Raptor and has a short range relatively. It was originally designed to operate in Europe, where combat ranges are typically measured in hundreds of miles for NATO fighters. If there's a conflict in the Pacific region, it would require much of a greater distance. Mid-air is cool, but then it also makes the NGAD jets less stealthy, and the airborne tankers makes them vulnerable to long-range missile attacks. This means that it's absolutely necessary for the jet to have a higher combat range solely on its internal fuel capacity. Plumes from afterburners are very easily detected by infrared search and track, IRST systems, and some radars. Higher top speeds are important in 6th-generation fighters because the speed of the launching aircraft directly affects the range of missiles. A faster aircraft can extend the range of missiles it launches. This becomes particularly significant when considering hypersonic weapons. This typically utilizes ramjet engines that can only be activated at supersonic speeds. Double delta wing. The design of the NGAD fighter is amazing as it incorporates a double delta wing, similar to what has been seen on an aircraft like the F-16XL and SOB Draken. This design allows for high speeds while maintaining excellent maneuverability at both high and low speeds. The wing has a high sweep on the inner panel, which reduces drag at supersonic speeds. The low sweep on the outer panel provides a superior handling in subsonic speeds. The NGAD fighter design takes it up a notch by modifying the outer delta wing. It doesn't have to have a triangular shape, but rather chopped. This is a complex modification, but a great way to enhance the jet. With advancements in computer technology and modeling since the F-16XL, this represents a significant leap forward in aviation design. NGAD cost and procurement. If the goal is to replace the entire F-22 fleet on a one-to-one basis, it would require approximately 180 NGAD fighters. The projected cost per unit of the NGAD fighter is staggering, amounting to several $100 million per aircraft. If this estimation holds true, it would make the NGAD fighter the most expensive weapon system in history. The Air Force and defense authorities will need to carefully consider the cost implications and weigh them against the strategic benefits and operational requirements of the NGAD program. Balancing the needs for advanced capabilities with cost efficiency will be crucial in the decision-making process. Collaborative Combat Aircraft CCAs. The proposed plan by the Air Force to acquire 1,000 collaborative combat aircraft CCAs is intriguing. What sets this plan apart is its vision of having 2 unmanned aircraft for every NGAD fighter or F-35. This implies a fleet consisting of approximately 200 NGAD fighters, 300 F-35s, and the remaining 500 aircraft being drones of various types and sizes. Contrary to popular opinion, these drones are not viewed as expendable assets. Instead, they're considered to be an affordable and mass-endowed force. Initially, the drones are expected to be employed in air-to-air roles. However, as artificial intelligence and tactics continue to advance, their capabilities can expand to include air-to-ground operations. This pool of 500 drones can be utilized in conjunction with either NGAD fighters or F-35, maintaining a 2-to-1 ratio of unmanned aircraft to manned aircraft. While the NGAD fighter is a groundbreaking piece of machinery, its cost is as significant as its capabilities. To ensure the success of the NGAD program, careful consideration of costs and the balancing of capabilities will be vital. NGAD production strategies. To achieve unprecedented air dominance, the NGAD program must prioritize efficient production, upgrades, and maintenance right from the start. One effective approach is adopting a modular design and common interfaces. These design philosophies involve dividing the system into smaller, reusable parts that can be easily connected and exchanged, similar to USB ports or Lego bricks. USB ports, for instance, enable seamless connectivity and interoperability between devices while reducing the need for multiple cables or connectors. Another strategy for NGAD development is allowing a more collaborative design effort, involving multiple contractors and stakeholders. In the end, the NGAD fighter's most significant challenge may not be its adversaries, but rather the same obstacle that hindered the F-22 program: a lack of sustained production and an insufficient number of aircraft. However, with a robust fleet, the NGAD fighter has the potential to dominate the skies like never before. Its long-range capabilities, supercruisability, and incredibly low radar cross-section are all key design goals that contribute to its air superiority. The ability to control the skies will depend on having enough assets to deploy and maintain air dominance. Next evolutionary step in air warfare. The integration of stealth drones into the NGAD platform is expected to revolutionize aerial warfare. These drones can be utilized for various tasks including reconnaissance, air-to-air interceptions, extending sensor range, and acting as a defensive screen. They enhance the capabilities of the NGAD fighter and make it a more versatile and advanced platform. In fact, there are discussions about the possibility of uncrewed versions of both the NGAD and B-21 Raider, indicating a potential shift in aviation history. This transition can be compared to how propeller fighters of World War II gave way to the jet age, marking a significant evolution in technology and capabilities. The winner of the NGAD fighter competition is scheduled to be announced in 2024. As more information becomes available, updates will be made to the 3D model and further insights will be shared. And that concludes our episode today. If you like this video, don't forget to subscribe and hit that notification bell. Have a good day.